So hello, my name is Natasha. I'm an incoming freshman at the University of Michigan, hoping to study biopsychology, cognition, and neuroscience, which was kind of just one big combined major, and then gender and health. And my project for Talaria focused on animal cognition, so what we know in the field, as well as what is left to understand. So I'll first start off with a brief introduction, to the study of animal cognition and its importance. So the way animals gather information and act upon it has been a topic of interest among scientists and even philosophers for several centuries. The official inception of animal cognition as a field of study is up for debate, with multiple theorized founders and start dates. So there was one Canadian English evolutionary biologist, George John Romanes, who published Animal Intelligence in 1882, but it really wasn't until the publication of American psychologist Margaret Floyd Washburn's textbook, The Animal Mind, in 1908, that people viewed as marking the true beginning of the field. So then I'll go into some definitions. So cognition is defined as the ways in which animals take in, process, store, and decide on to act on information from the environment. Behavior is the ways in which animals act, whether this be innate, instinctive, or learned. And then to touch on the relationship between cognition and behavior, it's uncertain whether cognition drives behavior or behavior drives cognition, or there's another relationship altogether. So some research has been done on this, and they're measuring the statistical significance between the two. So there is evidence of a small but statistically significant correlation between behavior, which is measured through variation in animal personality, and cognition is measured through variation in learning. But the direction of this relationship is highly variable, and the average effect size does not significantly differ from zero, meaning it's not a clear positive or negative relationship. So basically the field is still kind of deciding whether it's cognition that's the main driver or behavior, or if there's another relationship that we're missing. So why do we study animal cognition? So humans rely on animals for a lot. This can include food, production of goods, labor, and companionship. So it's important to understand the minds of these animals that humans rely so heavily on. We can also further understand complex cognition in humans by understanding how and why certain cognitive processes evolved in animals. So for example, the use of tools in chimpanzees has been an area of interest among researchers, as the evolutionary pressures that drove chimpanzees, but not other non-human apes, to use tools could be similar to or the same as for humans. So studying tool use provides insights into the challenges that chimpanzees faced, which might be scarcity of resources or inaccessibility of food, that drove the innovation and emergence of technology. There's also the social and cultural contexts that affect tool use, teaching of tool use, diversity of the tools used, and various uses for a singular tool, as well as how tools are used to manipulate or control external environments. And then we can also predict behavioral responses to new challenges. So this might be with climate change. There's obviously global warming, ocean acidification, also there might be some habitats that were normally there getting destroyed. So just all of the new challenges that come with that, even extreme weather events. So if we can predict animals' different behavioral responses to these new challenges, we can inform other areas like resource management, conservation, and also mitigation of human-wildlife conflicts, especially as there's increasing urbanization. And then we can also model different diseases and cognitive processes that we see in humans by modeling them in animals. So for example, there's a lot of research into aging that's done in animals. So understanding differences in the brain in normal aging versus with neurological conditions can show us what are maybe hallmarks or contributors to cognitive decline later in life. And then we can also study these study conditions that are characterized by cognitive decline. So maybe looking at neurodegenerative diseases. So what's the basis for these conditions, their progression in animals that might mimic the progression in humans, potential treatment options, all of that. There's also experimental drugs and treatments. We can see how it works in animals and how that might relate to how the drugs would end up working in humans, as well as looking at cognitive impairments and cognitive development. So if we can see kind of what changes from what we expect in normal development to cognitive impairments, then that has implications for how those cognitive impairments will manifest in humans as well. So on to my main research question. So are current methods of studying animal cognition achieving what they are intended to? And what aspects of animal cognition necessitate further inquiry? So within this, there are a few kind of sub-questions that I came up with. So is animal cognition a good proxy to study human cognition? Are researchers truly studying what they set out to do with current tests of animals' cognitive abilities? Can animals have cognitive abilities commonly accepted to be unique to humans? So this can include things like theory of mind, which is your ability to kind of think about others' thinking and understand that they have mental differences from you, as well as language, which is also commonly accepted to be unique to humans. And then do tests in a lab, which is an artificial setting, reveal animals' true cognition and behavior like they would in nature. So then on to the different methods of studying animal cognition. So the first one that I'm going to talk about is the study of model species. So this is looking at species like rats, for example, that can be used to understand the mechanisms behind certain cognitive processes, which can then be applied to understand how same or similar cognitive processes function in humans or other animals. So these species are used because they're easy to care for and handle, and they're often abundant in nature. So it makes them a lot more ethically appropriate to study than, say, like an endangered or less common species. So some drawbacks are that model species may lack the cognitive abilities that scientists want to investigate, such as theory of mind, which I previously mentioned. And while the study of model animals and animals more generally is a cornerstone of science, animal models may also underrepresent the complexity of human physiology as well as pathologies, and give rise to studies with very low predictive power, which limits their usefulness. And then findings from model species are limited in their generalizability to humans, just given the disparity in the complexity of human and animal systems. But this drawback can largely be addressed by the comparative approach to studying animal cognition. So in the comparative approach, species or populations are given the same or highly similar tasks to understand how and when cognitive processes might have emerged in evolutionary history and how current ecological and social conditions influence these processes. So this approach, however, is limited in that a sample of individuals from that species or that population is used to represent the cognitive abilities of the entire species or population, which may not always be accurate. Additionally, if one species values the test rewards higher than the other does, then there may be a difference in effort allotted to completing a said test. So that may not accurately reflect differences in cognitive ability. And then a third and probably less common approach to studying animal cognition is by studying genius individuals. So this kind of helps elucidate the existence or the limit of specific cognitive abilities that are found in a species. But studies of genius individuals may actually be misleading because not all individuals of the species or population from which the genius came necessarily have the cognitive ability identified. So maybe only the genius has this ability while other individuals in the species or population do not. And then genius individuals are often outliers that overestimate the cognitive ability of the rest of the species or population. So if you think of kind of like a bell curve, then the genius individuals would kind of be outliers on the right-hand side. And then finally, there are tests. So a variety of tests are used by researchers to study animals' different cognitive abilities. One of the most important being memory because of its relevance to humans. Memory is obviously an important part of our day-to-day lives, education, career, all of that. And then some specific examples are mazes. So mazes are employed to study the spatial memory of animals. And then another important example is avoidance tests. So they study short-term memory, so the ability to remember a past consequence and then avoid it by either moving locations or performing a specific action. So if an animal is exposed to a terrible smell and ringing a bell gets them out of that smell releasing, then doing something like that would be kind of like an avoidance test. And then there's also exposure of animals to novel environments or novel objects, which simulates aspects of human-animal interaction. So those three are all examples of these tests that researchers can use to gain insight into how animals will use new resources or react to new circumstances or challenges, or just to look at cognitive abilities like memory. So why is it so difficult to study cognition, which leads me into why I chose my project, being looking at what is left to understand in animal cognition, and then steps to kind of improve upon current methodologies and areas of future research to focus on. So some difficulties in studying cognition are that scientists cannot communicate with animals, and this means communicating with them in the same way that you could with humans. Like with humans, you could do interviews or have them fill out a self-report to go along with your study, but obviously animals cannot speak back to you, so that kind of limits that aspect of research. And then scientists are left to make inferences based on observations and different experimental data that they can collect, but it's not the same as if they were with talking with a human subject. There's also anthropomorphism, which is when humans project themselves onto animals. So if we see an animal doing something, then we might kind of assume, oh, they have the same motivations as a human does when they do that thing, or they do it in the same way that a human does, when in reality, they might have totally different motivation behind doing it or do it in a different way. Like they might do something that we think has one goal, but then it actually has a completely different goal. And then we're limited in kind of what we get from that interaction because of this anthropomorphism. There's also difficulties designing studies because you have to replicate the natural environment in an artificial setting and figure out methodologies that are going to measure the cognitive test, the cognitive ability that you want to look at, as well as the ethics of animal research. So making sure that the animals that you are looking at are being respected, taken well care of, and you're not imparting unnecessary like psychological harm or any of that. So just considering kind of all of the ethics to make sure that the research that you're doing is worthwhile, as well as not creating any unnecessary harm. And then, so further issues in the field of animal cognition to address. So this is more looking at the kind of research side of things. So there's some unclear or kind of differing definitions of terms and concepts in animal cognition. So one thing is just starting with the definition of cognition itself. It's most broadly defined as adaptive information processing, and then gathering information through the sense to make decisions and performing functionally appropriate actions, regardless of the complexity of any internal representational processes that behavior might imply. However, some researchers use a lot narrower definitions of cognition that fail to encompass certain cognitive abilities, such as perception. So even just starting from the definition of animal cognition itself, there's a lot of disagreement. There's also a lack of test validity. So there's different kinds of validity. So construct validity refers to the extent to which a test accurately measures what it aims to. and thus to what extent inferences can legitimately be made using that test. And then there's also face validity, which refers to the extent to which a test is subjectively viewed as measuring what it aims to. So if you look at a test, would you say that that is measuring the cognitive ability? So face validity is frequently assumed since it's so subjective, but not always confirmed. And face validity may also be confounded with construct validity, which makes it difficult to validate these different methodologies in animal cognition study. And then cognitive performance of these evolutionary distantly related vertebrate taxa, such as mammals and birds, are evaluated and compared using the same tasks and the same test setups. But because not all individuals or species tested may possess the sensory abilities to perceive the test and distinguish the test stimuli, the motor skills to handle the test setup, and sufficient motivation to perform the task, then the cognitive test may not be fairly measuring the performance or the abilities of these two species, and differences found may be due to effort that's put into the task and or the sensory and motor abilities, rather than differences in cognitive abilities. So there's still a lot that needs to be done to kind of validate that these tests are actually measuring what we as scientists want them to measure, as well as how we can use them to compare between different species or different populations, because they may not have the same kind of base skill set to handle the test. And then if they don't, then that will lead to a lot of differences, as well as looking at effort. If animal A really values the reward that's given for the task, but animal B doesn't really care all that much, then animal A will obviously put a lot more effort in, and then that will change the end results. And so the results that we see may be different because of the effort, not actually the abilities of animals A and B. And there's also a lack of repeatability. So that would be variation in successive measurements of the same variable measured under the same condition in a short period of time. So it may be difficult to kind of repeat the same test since it is in an artificial condition. And then it also may be more difficult to repeat in nature. It's difficult in nature to establish this kind of repeatability compared to in an artificial setting. In an artificial setting, you can just give a test again, but that may be different if yours is more of like an observational type of study. And then also tests in labs may not actually reflect an animal's true behavior, because it's just a lot more distilled down version of what happens in nature and may not be kind of accurately representing how things would work in nature and how an animal would actually respond. And then the last issue is kind of touching on effort, which I spoke about before, but looking at how much effort an animal puts in, because if the animals have different evaluations of kind of the reward. If one values the reward very highly and the other doesn't, then that leads to differences in effort, which then lead to differences in results, but the results may not be different because of cognitive abilities, but rather just that effort piece. So the field needs to move towards isolating and quantifying kind of an effort variable to see how animals' cognitive abilities, just regardless of that effort, affect their performance. And then, so here are some steps to improve on current methodologies, as well as areas for future research that I proposed in my paper. So first would just be clarifying definitions of those terms and concepts. So I think first and foremost would kind of be just clarifying the definition of cognition itself. So should that include cognitive abilities like perception, and kind of choosing one main definition. There are commonly accepted definitions, but still kind of clarifying that piece of what we should actually include. Validating current cognitive tests. I mentioned the issues with construct and face validity. So making sure that we are validating the tests that we're currently using and seeing if there are methods to improve upon the validity of those tests, as well as isolating and quantifying effort by animals in these tests, so we can kind of take out that confounding variable. And then some main areas of future research would be theory of mind. So it's still up for debate in the scientific community as to if animals have theory of mind or if theory of mind is unique to humans. So in 2019, evidence was found of sensitivity to desires in scrub jays and also sensitivity to beliefs in apes, so which some researchers believe to indicate having theory of mind. But further research is needed into if these sensitivities extend to other species and if non-human animals exhibit other kind of hallmarks of theory of mind. And then another area of promise is computational models of animal cognition. So computer scientists can consider animal brains as kind of a node in a big network. And so that would represent the complex interactions in the nervous system, with the brain being a node, and then behavior would be an output or a response of this system. So using new technologies or like machine learning, evolutionary computing, researchers can gain insight into more of the nuances of cognitive processes, as well as looking at how such processes might have evolved and making predictions there. Looking at how cognition affects behavior and kind of delving more into that relationship, and predicting animal responses to different stimuli or situations. And computational models of animal cognition are being used to quantify and represent different subjective phenomena, such as animal well-being, which is something that we haven't really been able to do before, and computational models may kind of be leading the way in those areas. And then finally, computational models obviously do not involve real animals, so this can help kind of ensure ethical animal research, as well as if we're able to quantify, animal well-being, then that can also help ensure more ethical research that's kind of prioritizing the well-being of animals. So I would like to acknowledge my mentor, Dominic, from the University of Sherbrooke, for his guidance as I conducted my research and wrote my paper. He was super helpful in always answering questions, just kind of like talking through ideas with me, explaining a lot of different aspects of just what animal cognition is and like what the different methodologies are, and kind of making the link to behavior really clear. He has a background in ecology, whereas I was approaching it more from the psychology piece. So kind of just helping me bridge that gap and really understand what are the main priorities in animal cognition and just kind of where to go and where to look, and which areas to kind of focus on and prioritize. So I just wanted to thank him for kind of walking me through all of that. And then just to briefly kind of touch on my research experience. So mine was basically had to be more of a literature review. There was some mixed up with like contact info and stuff. So I started the program a week late. So I was kind of limited in being able to do things like data analysis and like my own original data collection. So we decided to just do a literature review, but I still thought that was really fruitful. I think I've never really looked at like a field as a whole, like animal cognition. I've more focused in on kind of a very niche, very specific subject within a larger field. So I thought it was interesting to kind of look at like what are the current methodologies and what can we do to improve upon like an entire field. I thought was a very, very different point of view than what I had done previously. And just kind of mapping all of that out and also making connections to like computational models and looking at like the well-being of the animal subjects, which I'm not sure is always really touched upon in research, and just doing more of like a literature review type of project rather than data analysis, I thought was interesting, but allowed me to really go very in depth into the topic and kind of gave me the space to really like dissect each aspect of like what do we understand, and then really laying out my suggestions for what to do differently in the field. So I thought it just afforded me a very different perspective than research I had done in the past. So very happy that I got to do this project.